Hello and welcome to the second video for FTC training in the second playlist. As usual, my name is Anton and common guest Raj, and special guest now we have Akil. Akil, say hi.
Hello.
Yeah, Akil, if you want, you can introduce yourself.
Hello, I'm Mikhail. I'm the VP of Manufacturing for FRC, and I oversee fabrication of robot parts, assembly, and electrical.
And Raj does not need an introduction because you probably already know him. So we're going to talk about how to manufacture some CNC parts later on for FTC, so that should be some fun. We're also going to cover some Featurescripts today, and also just some general Onshape rules for creating parts. Featurescripts are basically kind of extensions for Onshape. They help a lot when creating parts or like when creating really common parts, especially on robots, because they save a lot of time. The ones we'll be covering today are, let's see, it's going to be extrude individual, gusset, lighten, and spacer, yes. First, you will actually have to add these onto Onshape, so let me show you how to do that. First, you want to search up Julia's Featurescripts, and then you can go to the FRC design link right here, and then scroll down and go. You can just click on the extrude individual one right there. And now what you want to do is you want to copy the link of this website and then go back onto your Onshape document. Go into this very kind of drop down all the way to the right and press add custom features, and then see how it says paste URL. So you paste URL on there, press return, and you should see Julia's Featurescripts. Go into Julia's Featurescripts and then click on extrude individual, gusset generator, spacer, and then for lighten, okay, so I'll probably just paste this in the description of the video, and then you'll be able to add this onto your document or onto your Onshape. So just do the same exact procedure as you did with the other Featurescripts and it should be working. So first we will talk about the lightning Featurescripts. So when making CNC parts, aluminum tends to be pretty heavy, or any metal that you're working with, and tends to be heavier than, of course, 3D prints. So a very common practice is to lighten them, or basically to remove material, but not to ruin the structural integrity of them. So let's just say, for example, I have a plate here. So now what I do is I have to create another sketch, and you have to start kind of drawing lines from these holes to, well, kind of wherever feels fit. So I would say follow me for now, and then I will explain why I'm drawing lines this specific way in like 2 minutes. But first, you should actually notice that I am drawing out triangles, because triangles are the strongest shape. And so using them instead of, for example, a square will lighten your part, will make your part, a lightened part, a lot stronger. So now that I've created these 4 sections, I click check mark and I go onto my lighten and I press on it. Just copy down these values right here, 0.4, 3.2. And now you just kind of want to click on these sections. So as you see, it basically created holes kind of in between my lines, right? And they're all triangles. Why did I create these lines in this specific way? Like, why did I all merge them in the middle of the part? Well, because you kind of want to think about lightning as a bicycle wheel. So if you imagine, let me just search it up, bicycle wheel. As you can see, they're all connected to like the center of the wheel, right? And you can treat these spokes as your lines in Onshape, and you can treat the hub or the center of the wheel as, in our example, the center of the plate, or you could also just have a hole there, right? And you generally just want to connect all of your lines from the edges of your part to the center of it, or to the holes in the center. So going back to lighten, what you can also experiment is the thickness of the walls. So if I change this, you will notice that the thickness of my walls like drop or increase depending on what you do. General rule for this is you generally want like a 1/4 inch or 0.3 inch thick parts. And if it feels still pretty thin, just use your gut, right? Just experiment with the values, see what works. Like this feels too thick for me right now, so 0.3 feels fine. Let's say that in my part, I have another hole, like I have two holes, maybe one right here and one randomly right here. Well, now what do I do with my sketch, right? If it shows up in extrude. Okay, so now what do I do? How do I connect my spokes to the hubs? Well, now you can treat these two center holes as two hubs in your part. So I would make a line right there, and now like you can decide where you want to connect them. So I can decide to connect it on a midpoint, which looks pretty good to me. You can decide again with your gut wherever else you want to connect it. And then what I would do is I would connect these two spokes together like that and probably do something like this and then form another triangle here. So as you see here, this is not a triangle. This is, I don't know what this is called in geometric terms, but this is also fine. You just don't want your part to be made of like 50 of them, right? You want to aim for triangles, right? So now I have like 1, 2, 3, 4 triangles that, well, almost triangles. And then so now I press check mark, go into lighten, and select on every single space like that. And it made a pretty cool part. So really try to use this when you're making CNC parts, especially if they're pretty big. This will take time to get pretty good at it, but as usual, I'm always here. So if you have any questions, just feel free to ping me. Moving on to the gusset feature scripts. So a gusset is essentially a plate that connects two things together. I'll go into actually our FRC robot doc and I'll show you some examples of them. These two plates over here definitely are gussets, right? They're quite literally just plates with holes that connect one thing to another thing, right? And creating those plates by yourself can be pretty tedious, especially with all the sketch thing and the extruding thing. So luckily, a feature script already exists. So let's just say, for example, I have a hole here, a hole here, and a hole here that I want to connect, right? And let's just say I want to connect these 3 holes together. This is really, really easy. I go into the gusset feature script. I select the thickness of my gusset. I select the offset edge width. I will leave this at 1/4 inch. You can also play around with it if you want. Leave all of these kind of settings, like just copying it down from me. And 6061 aluminum, yes, we will talk about it later. And for holes, you just select the holes you want to make a gusset out of. And cool, created a little gusset for you. This is really, really useful, and you can also just edit it as well. Just make a sketch on it and remove material. Speaking of material, I want to talk about the thickness of metal that you might be using. So the ones that we have in shop right now, I think Akil knows more than this than me. Akil, if you want to talk about this.
So materials we have, at least for FRC, we use mostly 1/8 inch aluminum, 1/16 aluminum, and then for plastics, we'll usually use 1/4 inch. We do have 1/4 inch aluminum, but for FTC, I wouldn't worry at all about the size because whatever material you want to use, you can provide it, and we'll just like do it for you.
So I would say the most common ones you'll be working with will be probably 1/8, maybe even 1/16 inch. So yeah, I'll leave it as that. And then the material you guys have, well, you guys can cut is for, at least for aluminum, is 6061 aluminum, which is kind of like the general one that is used across FRC. It's generally strong. It's not as expensive as other aluminum types, and like it's kind of just the standard. And then another one that you guys can use is 5052, which is a type of aluminum that is used for bending.
So 6061 is what you'll mostly be using. It's really common. It's widely available, and you can bend with 6061. It's just that it's a lot more rigid. If you wanted like really extravagant bends or something, then you'd probably want to use 50-52 for that. It's a little less stronger, but it's a lot better to bend. But it depends on what you guys want. And
So that is the gusset feature script and everything about materials. I will now explain the extrude individual feature script, which is actually pretty self-explanatory. So let's just say, for example, I have a rectangle here and another rectangle here that I want to make two separate parts. If I go into the extrude on Onshape and I press these two, I can either make them one part, so part two, or I can add it onto an existing part. So it's we're gonna if to make these two separate parts using the Onshape extrude, I would have to extrude this rectangle first and then go and extrude the other rectangle first. So extrude individual is pretty useful because it just makes two, separate parts of two sketches that are coincident with each other. A spacer is exactly what it sounds like. It quite literally spaces things apart from each other. So going back to, we use these basically all over our robot. You can see that these two polycarb plates over here are spaced out by spacers, right? Um, these two plates are spaced out by spacers. We even use them on shafts right here. So a very, very versatile kind of and very simple thing to make. So you definitely do not want to be spending time just sketching out every single spacer. You will want to click on a hole and then select the spacer type you want. So this feature script was created for FRC. So the shaft standards for FRC are 1/2 inch and 3/8. But again, I don't know what the shaft standards are for FTC, so you probably will have to experiment with this a little bit. But you'll probably be using round a lot, and then for external diameter, you can honestly just play around with the feature script and see what changing each setting does. So yeah, Raj, if you have anything to add on to the shaft standards in FTC.
Yeah, I actually had a question. So, does the like for some shafts, they're like hex instead of just
Mm-hmm.
round? Does this like feature script allow you to work with that?
Yes. So this is for example, a 3/8 inch hex. You'll be able to change the spacer type. So for a 3/8 inch hex spacer, I will do a 0.07 add-on, and then external diameter I'll make like probably even more, 0.75 here. We'll do that. So as you see, a hex shaft can now go through it. Um, I don't know, like there aren't any other options for types of hex shafts, so you might just have to actually just sketch out the spacer outer diameter first, and then extrude it, and then use the polygon tool in the sketch to create the central shaft hole. Back in the FRC document, I mentioned polycarb. Polycarb is a very, very strong yet very, very light material, but it also costs a lot. Um, you guys also have access to this. Akil, if you want to touch up on this a little bit.
polycarb, its benefits are that it's kind of indestructible. The reason you'd use polycarb instead of acrylic is very prone to impacts. So if you impact acrylic wrong, it'll just shatter. For polycarb, it doesn't do that. It stays intact. It'll either just bend a little bit, but then come back to shape. But like Anthon said, it is a lot more expensive.
Yeah.
But
And then it's usually used for like high impact areas. So, for example, for robotics, we all do crash into other robots. But for FTC, Raj, I don't know how useful polycarb will be for you guys.
Yeah, contact is definitely less. I mean, maybe in a few areas where there would be more, but yeah, I don't see too many uses for it.
Yeah. And then, Akil, can you tell them the thicknesses of polycarb that we have or that we can cut?
we can cut any thickness of polycarb really, as long as it's like thinner than 3/8 of an inch. And if you're using 3/8 inch of any material, I think you're preparing for doomsday. So
Yeah. So for spacers, a very important thing is tolerance. What is tolerance? Tolerance is the space between two parts that kind of come together. So, for example, for this spacer and this plate, I did not make the inner diameter. Like if I hover over the spacer, you can see that the inner diameter hole of my spacer is actually larger than the hole for the plate itself. And this is actually to give clearance or tolerance for the screw that will go into here. Because if I made the inner diameter of this hole the exact inner diameter of this plate hole, then it is going to be a very big pain trying to get the bolt through the spacer and through the hole. So yeah. And then for deciding on how much tolerance to add, I would honestly just use your gut feeling. You can do multiple 3D prints of any part. So if it turns out to be too loose or too tight, you can easily just change it and then reprint it. Raj, anything else to add on to that or any questions?
I guess like one question I had is like how does tolerance differ between like different material types you choose to use?
I'm gonna pass this on to Akil because I probably am talking a lot of gibberish right now.
So the tolerances for each material largely depends on how it's being manufactured. Um, like what Anton was saying with 3D printing, we use fused deposition modeling, where it sets down a melted layer of plastic and it waits for that to essentially harden before it puts another layer on. And due to thermal expansion, plastics will actually expand and contract due to temperature changes. And so what you'll notice is when you put down a layer, the old layer of plastic is actually going to contract a little bit. And it'll basically, for holes, it'll make it smaller. And so when you add tolerance, you purposely design it so it's slightly larger and it'll account for that like play. For metal parts, it again depends on how you're manufacturing it. Let's say you're CNCing it, it's a little more forgiving because you can actually ease up on that dimension a lot better. But you still need to add tolerance because there's always going to be small little like deviations in how it's manufactured. It's never going to be exactly how you want it.
And the expansion of 3D printing is not that significant. Like it's maybe like I don't know 0.2 millimeters. Akil, I don't know if you know exactly, but
When printing with PLA on bamboo printers, you can rely on about 0.1 millimeters of tolerance. So it's really good.
yeah. So you don't really have to worry about that a lot with 3D printing. Speaking of CNCs, Akil, can you explain to our audience what that is?
Yeah, so a CNC, it's a tool used for manufacturing parts. There are several types of CNCs. There's something called a CNC router and a CNC mill. But first, CNCs, they stand for computer numerical control. And it's essentially a system that is using code you give it from a computer to execute something. And a lot of times it's either 3D printing or cutting something. So yes, 3D printers are technically CNCs, but a different type. So there's additive and subtractive manufacturing. Additive is like 3D printing, so you're building something up. Subtractive is what we mainly use with the CNCs, and that's where we're using a bit that's spinning really fast and it's cutting away material to give us the part we want. So for us, we're using CNC routers, and it's a very large 3D printer, you could say, but with a few constraints. And you'll put in a sheet of material, and you'll give it some code, and it'll run a bit along it to cut out your part.
Yep. And then I'll.
You could see some videos here.
Yeah, oh, I don't want to get copyrighted. Gotta make the FTC money. So yeah, it's basically just kind of like a power drill, but on steroids.
So the part that's spinning really fast is what we call an end mill, and it's just a piece of metal, either carbide or high-speed steel, that has cutting edges on it, and it spins really fast and with a lot of torque, just goes through metal.
Yep. And then as you can see here, this CNC can cut stuff at an angle. Ours, sadly, is that sadly, Akil?
Uh, Not really. We don't have a purpose to have a fourth axis.
Yeah.
Um,
So our CNC
a lot
can,
of times you're mainly just doing 3-axis machining. So
yeah. So yeah, our CNC can't do that. It does what this. Oh, our CNC also can't do that. Yeah, it does what that CNC does, but it's still very very useful. And as Akil said, we probably don't need a fourth axis. Moving on. With creating parts for CNCs, there honestly isn't a lot of rules. I asked this question. I asked how I should create parts for CNCing because to my design mentor, because for the past season I've honestly been eyeballing and gut feeling a lot of parts, and he generally replied to me that like for now gut feeling is probably the best thing to do. And generating this gut feeling takes practice and takes time. So if you have again any questions on any parts that you want to CNC, feel free to ask me, Raj, Akil, anyone with, I guess, a developed gut feeling. So now let's talk about some CNC rules for FTC, which, Akil, I was assuming that FTC there's like a procedure for them to use in CNC, or like when they can use
oh
in
yeah,
CNC.
yeah, okay. Procedure to submit a part to be CNC'd is there will be a form where you can submit a fabrication request, and you'll use this form for 3D printing as well. And either your lead or someone on your team will be designated to submit these requests, and we will receive the file from you. We'll receive what the part is, and there'll be a whole like guideline stock that you have to make sure your part conforms to, so that we can actually fabricate it. And then if it aligns with all of that, we will take it, we will fabricate it, and then we'll bring it to you guys. And then there are lead times associated with that.
And
That's
then
mainly the big rule. The other like guidelines for it are more design aspects. So I'll let Anton take care of that.
yep, and then for materials they will have to buy that themselves and provide it themselves, right?
Yes, but there are exceptions which we can talk about when there's a part that needs to be made.
Yep. So, to kind of touch a little bit on designing parts for CNCs, um, all custom parts for any first robotics for FTC or FRC should definitely not have corners, especially CNC parts. Judges usually hate seeing corners on your parts. Like, hell, we even actually like take out files on our FRC robot and actually file corners down. You definitely use the fillet function for any corners. For example, for this plate, I would definitely use the fillet function for here. And then we will also talk about why fillet is very useful for 3D printing, which is in the next video. Akila, Raj, you guys have any thoughts on this or any questions, comments?
Filleting is also really important when it comes to inside corners because the CNC cannot give you a sharp inside corner. There's always going to be a radius there.
Yep. And that depends on the diameter of the drill bit, right? Or the radius?
Mm-hmm. And mill.
I'm the design lead, guys. And what's the minimum? Like, using the smallest end mill that we have, what's the minimum radius that we can make
so their smallest end mill, it's an 1/8 inch end mill, and the smallest inside corner radius you can get is half that, so 1/16.
So what we mean by inside radius is, for example, let's just say I want to make a part inside, or like I want to make this kind of a frame, and I want to remove this center part of it. So this is what it's called an inside corner. Akil, correct me if I'm wrong.
Nope, that's right.
Yep. And the smallest radius that this inside corner can be is, Akil, you said 1/16?
1/16.
Yes, 1/16. And that is because if it's anything smaller, the end mill will physically not be able to like cut out that section of your part. And what it'll do, Akil, again, correct me if I'm wrong, it'll just skip over it.
It will still cut there. You'll just get a radius there no matter what.
Oh, all right.
If you need a sharp inside corner, there are ways to do it, but you're gonna have to communicate that with us, and then you'll have to make a few design changes to allow for it.
Yeah, so general rule, no sharp corners. Akil, if you don't have anything else, I think that's it for manufacturing.
Cool. Adios.
Yeah, thanks so much. Now we will start talking about just general Onshape rules and other features that you should know. So a very important thing in Onshape is making sure that all of your sketches are constrained. What I mean by constrained is that you cannot click on them and move them with a mouse. So see how I just did there? I can move and change the dimension of this shape with my mouse. So the only time this is acceptable is only when you expect a change to happen in part, because then you can easily just change the dimension of it. But generally, this is very bad when catting. You want to make sure that your whole sketch is constrained. And I highly recommend using more geometric constraints than using the dimension tool. So for example, for these two, like this pair of rectangles, I would probably just coincident the midpoint to the origin of the UI. The origin is probably going to be the first thing that coincidences. So yes, in your very first sketch, make sure that your features are coincidented. And then now what I would probably do is I can make this side and this side equal, right? I'm trying to use geometric constraints, and then I can dimension them to say 3 inches. And then what's a really easy way to do or to check what is constrained and what is not constrained is quite literally just use your mouse. So press and hold on anything that's blue and try to move it. That is then you'll know what to coincident. And then now what I'll probably do is I'll make the widths of the two rectangles coincident, and then I will make them attach a dimension to on them. So as you notice, I did not really have a goal for this part. I was just kind of making as I was going, but I used only 2 dimension tools. The rest were all equals, were all midpoints, were all coincidence. Something that would be bad is if I, for example, did this. If I made this side and this side 2 inches, right? This is just a waste of space, and it's gonna make viewing your part a lot harder. There are actually some features that I prohibit you to use. One of them is fix. So just to show you what fix does, it kind of just sounds like what it does, right? It fixes stuff in the UI. So for example, I made this rectangle that is unconstrained right now. If I run fix on it, it becomes constrained just in space, right? With no actual purpose. Do not use fix as a band-aid. You really want to make sure that all of your coincidences, all of your constraints, all of your dimensions have a purpose. Another thing I would not do is I would not use fillets in sketches. So let's just say I add a fillet here, I add a fillet here, and I add a fillet here, and I add a fillet here, right? And then now I can extrude it. But problem is that making fillets on your sketches will make it kind of really hard to edit the original geometry, because the original geometry is not with these curves, right? It's with the sharp edges. Fillets make it really hard to, especially when you have a lot of them, and when you have them on a pretty technical part, it makes it pretty difficult to change the original dimensions, like the natural dimensions of your part. So I highly recommend to do fillets after you've created the original kind of rough sketch or rough draft of your part, because they're supposed to be kind of like an add-on feature anyway, and that should also save you some regeneration times. And the last thing I want to talk about during this video is symmetry. Symmetry is really, really important in Onshape and in CAD. So for example, looking back at the cookbook holder I created for my mom, you can see that everything is, well, at least without the decorations, let me suppress those, everything is mirrored. Like I can mirror this whole part over the right plane and it'll still be the same part. So I basically created this in a way so that it is mirrored over the right plane. I didn't create this so that this side is coincident with the right plane. I made it to be symmetric. And this is really, really important, again, as I said, especially for layout sketching, as we'll get on later. The very first step that you want to do to make your parts symmetric is actually via the extrude function. So let's just say I want to make this square symmetric over this right plane, right? And it's 4 inches long. Right now, it is definitely not symmetric, right? It is sitting to the right of the right plane. So what would happen if I tried to mirror it is this would give me an 8-inch long rectangular prism. I want a 4-inch long rectangular prism. So what do? Is I make it symmetric. And now, as you see, it made this rectangular prism it made the middle of the rectangular prism sit right on the right plane, making it all symmetric. And then this is also where mirror comes to play. So mirror is gonna be really, really useful, both in the sketch and in the Part Studio. The one in the Part Studio is a bit more tedious to work with because you can't select lines you want to mirror over. You actually have to select faces or planes. So, for example, if I did want to have an 8-inch long rectangular prism, I would create one side that's 4 inches, and then I would select the mirror option, press on this part, and press add since I want to make an addition to the current part. And for the mirror plane, I would select the right plane and merge scope 5. And yeah, what could happen is that you get an error saying that like it overlaps or something. Oh, this is for features only, by the way. There's this drop down here. So you can mirror parts, you can mirror features, which is actual just like individual features in your feature list, or you can mirror faces. I don't really use faces. I either use one of these two. But when you're using feature mirrors, usually you will get a very angry red Onshape. And to fix this, you just say reapply features and you just call it a day. And yeah. That is it for the video, unless Raj has something else to add on or any other questions. See you in the next video for 3D printing.